Okay, Chapter 4, Describing Data, Displaying and Exploring Data. Luckily, for this chapter, I took out a lot of slides. We only cover the main point. Our goal will be compute and understand the quartile, decile, and the percentiles, and compute and understand the coefficient of skewness. The standard deviation is the most widely used measure of dispersion, and alternative ways of describing spread of data, including determining the location of values that divide a set of observations into equal parts. These measures include quartiles, deciles, and percentiles. So quartiles, from the name, you can tell it's about we divide a set of the observations into 4 equal parts. Decile is divide a set of the observations into 10 equal parts, and the percentile into the 100 equal parts. Then how do we find out the location? And the formula of the location of the percentile is L sub p equal to n plus 1 times p over 100. So we let LP refer to the location of the desired percentile. So if we wanted to find the 33rd percentile, we would use the L33, and if we wanted the median, the 50th percentile, then it's L50th. The formula we just introduced in the last slide. So the number of observations is n. Here n is the number of observations, and so if we wanted to locate the median, its position is at n plus 1 divided by 2. That's also, if you can remember, that's our the question in the chapter, week 3 homework. Or we could write this as n plus 1 times p over 100, where p is the desired percentile. Because we know for the median, we want to find the 50th, so 50 divided by 100, it's it's a half. So that's why we get the n plus 1 over 2. How do we understand that formula? Let's check the example. Listed below are the commissions earned last month by a sample of 15 brokers at this company. Locate the median, the first quartile, and the third quartile for the commissions earned from these numbers. First step, we organize the data from the lowest to the largest value. Our purpose is to try to find the location of the 25th and the 75th. So step 2, we compute the first and the third quartiles. Locate L sub 25 and L sub 75 using this formula. So bring the first one into the formula, we get the L25 equal to 15. There are 15 observations. 15 plus 1 times 25 over 100. We get a number is 4. And for the L sub 75 equal to 15 plus 1 times 75 over 100. We get a 12. That means the first and the third quartile are located at the 4th and 12th position. Respectively, it's the number 25th is 1721, and the number 75th is 2205. We can check the last slide. See, it's respectively it's here. The two numbers is here and here. So again, this formula help you find out the location of the percentile. Next, let's introduce the skewness. In Chapter 3, measures of the central location, the mean, median, and the mode for a set of the observations, and the measures of the data dispersion were introduced. Another characteristic of a set of data is a shape. There are 4 shapes commonly observed. symmetric, positively skewed, negatively skewed, and a bimodal. We use Pearson's coefficient of skewness. We use this formula to calculate the skewness, and you can ignore this one. For Pearson's coefficient of skewness, this skewness can range from the -3 up to 3. A value near -3 indicates a considerable negative skewness. A value such as 1.63 indicates moderate positive skewness. A value of 0, which will occur when the mean and the median are equal, indicates the distribution is symmetrical and there is no skewness present. So also you can tell if the coefficient of skewness is 3, that means considerable positive skewness. So what's the shapes of the skewness, the skewness of the distribution look like? Let's take a look at these graphs. The first one is the symmetric. The skewness is 0. For the symmetric distribution, the mean, median, and the mode are the same. For the positively skewed, the mean is greater than median and greater than mode. So just remember why for the positively skewed distribution the mean is greater than median. That's because of mean is affected by a few extreme large values. And the negative skewed, for the negative skewed distribution, the shape of the curve look like this. The mean is smaller than the median, is less than the median. So why is it so? Because the mean, at this case, the mean is affected by a few extremely small values in the data. So look like this, and this is a bimodal. Okay, for this kind of the case, there are at least 2 modes. Okay, let's come back to take a look at the Pearson's coefficient of skewness formula again, because we need you learn how to calculate this in your homework, and it may appear in our exam. Skewness equal to 3 times x bar minus median and over standard deviation. So x bar again is the sample mean, and the median is the median value of a set of the data, and S means standard deviation for the sample data. Okay, let's check example. Following are the earnings per share for the sample of 15 software companies for the year 2007. The earnings per share are arranged from the smallest to the largest. So the questions are: compute the mean, median, and standard deviation. Find out the coefficient of skewness using Pearson's estimate. Second, what's your conclusion regarding the shape of the distribution? Okay, first one, let's find out the mean of this sample data. Is x bar. Again, x bar represents the sample mean, and we use mu represent the population mean. It's different. So x bar equal to the sigma x. Again, sigma represent indicate the operation of the ending. Sigma x over n equal to 74.26 and divided by 15, and we get the 4.95. Step 2, compute the standard deviation. So okay, pay a little bit of attention here is because this group of data are samples. They are samples, they are not a population, so we use S. Okay, S indicates the sample standard deviation instead of the sigma. We use the sigma represent the population standard deviation, but we use ice represent the sample standard deviation. Another difference is the denominator for the sample standard deviation is n minus 1, but for the population standard deviation, the denominator is n. Some of our students made this mistake in their last week's homework. Okay, the formula is ice equal to sigma x minus x bar and square it. Then we sum all the values up divided by n minus 1, and then we take the square root. So the result is 5.22. Okay, I will just want to explain. When the formula is x minus x bar, then x bar means sample mean. We get this number here, right? So 4.95. And this x means any particular, the values in the data. So we need to try all the values, all the different values, try each value to minus the average number, and after we got the result, we need to sum all the result up. So that's the formula. Step 3, find the median. So the middle value in the set of data arranged from smallest to the largest is the middle one is 3.18. Step 4, we can compute the skewness after we found out the mean and the median and standard deviation. So skewness equal to 3 times x bar minus median and divided by the sample standard deviation. So we get the 3 minus 4.95 minus 3.18 times that, and over 5.22. 5.22 is the standard deviation. Then we get a 1.017. So the result is a positive, means this is positively skewed, and not considerably, it's just moderate. Okay, that's it for this week, and just letting you know the concept, understand the concept of the mean, median, and standard deviation is very important, and how to calculate them. You can find out all of these values, including standard deviation, like for 2 seconds using the Excel. But why I still like you try to calculate these steps, just let you understand how do we get the standard deviation. So standard deviation always use each value minus the mean number. So now you can get, because for us we try to find out the center of the data, and sometimes the center of the data cannot really represent the whole data. Why? Because of skewness. See, the skewness exists. So for the data which is largely dispersed, and they will have the big standard deviation number. Standard deviation number. What the big standard deviation number means each value is really away from the mean number. So if standard deviation is a huge number, then that means the mean number, like the x bar or the mean number, is not so representative. Okay. So again, if you have any questions, please send me email, or you can ask me questions in my face hour on the Moodle, the big blue button. Okay.